All right, let's look at factoring trinomials. What's a trinomial? You know what? I don't even want you to answer. I'm just going to go ahead and tell the answer. Oh, Mr. Crane, you're just so rude. I can't believe this. Let's just do this. X squared plus bx plus c is your normal trinomial. And what we want to do is to look at first things where a is 1. First, let's look to see what happens when a is equal to 1. That's when things are nice and easy. Remember that? Yeah, right there?
Yep.
I do this example every time. It's a good one. X squared plus 7x plus 10. Now, remember, when we're factoring these guys, we're unfoiling, however you want to say this. And when we're unfoiling, you understand where things come from. X squared came from multiplying the first pieces. The 10 came from multiplying the last pieces. But the 7 is a combination of the outside and the inside. So, when I'm factoring this, we expect this to come from the product of two binomials. Okay? So the first terms came from the first pieces of this product. How do you break down x squared?
X or X.
All right. And then the 10 came from the product of the last terms. It came from multiplying this guy with that guy. Now there's more than one way to break down 10 using integer values. You have 1 and 10, you also have 2 and 5. Which combination do you want to use?
2.
You want to use the 2 and 5 because why? You multiply to get 10, but it's going to add to give you 7. So I use 2, I use 5. Everything's positive. Do y'all agree? Does this check out? When you check your inside and outside pieces, inside is a plus 2x, outside is a plus 5x, so altogether it's a plus 7x. We remember this? Alright, let's just run through a few examples and we're going to put some problems on the board for you. Just want to make sure that we do remember the basics of factoring trinomials. 5x squared plus 3x minus 80. Now, if you were going to factor this guy, you'd probably break down the x squared as x and x, right?
Yes.
What about your signs? You have one positive and one negative because you have to multiply to get a negative 80. Think about the factor pairs that you have that make up 80. You have 1 and 80, 2 and 40, 4 and 20, 5 and 16, 8 and 10. Now the question here is that since these guys have different signs, can I find two numbers that will give me a difference of 3 from what I have over here? Is there any factor pair that's going to be off by 3? So I don't see anything over here, so will anything work if I put the numbers in here? I'm not going to get anything to work here. So what do you think I should say? There's no GCF. This guy can't break down at all. What do you say about that? No solution? I don't see that this is an equation that I'm solving, so no solution is not an appropriate response. This is prime. There's no factoring that can be done here, so we just say prime. So you need to watch out for that. Okay. Let's change this up a little bit. X squared minus 9x minus 70. Is there a common factor to take out of everybody? No. It's a normal trinomial, so we expect this to look a certain way when I break this down. I expect x squared to break down how? X times x. What do you know about your signs? Because you have to multiply to get a negative 70. One positive, one negative. Now, how can you combine a positive and a negative to get a negative 9 when you're adding?
Negative's got to be bigger.
The negative is going to have to be the larger of the two factors. So let's see if we can figure this out. How can I break down 70? If you're not sure, you go through this systematically. I got 1 and 70. Does 2 go into 70? 35 times. Does 3 go into 70? No. Does 4? No. Does 5? 14 times. If 3 didn't go in there, 6 would not go in there, or any other multiple of 3. 7 and 10 is going to be the last combination that we have. So are there any numbers that are going to work here for us?
14 and 5.
14 and 5, so what goes where? Positive 5, negative 14, right? When you check this, you get a plus 5x in the middle, negative 14x on the outside, so altogether we have the negative 9x we were looking for. Questions about that?